We're going to finish up the final exam study guide. So I left off on number 49, so that's where we'll start. Determine the asymptotes, domain, range, and end behavior of exponential and log functions. So might be good just to have in mind. Let me get 2 pieces of graph paper. These are inverse functions, the exponential function and the log function. So might be a good idea just to make sure we know what they look like. So this is 2 to the x, f of x equals 2 to the x. This is the exponential function. So 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, and it has a tail through there, and an asymptote at 0, at y equals 0, a horizontal asymptote at y equals 0. That's 2 to the x. And then its inverse function is log base 2 to the x. So all the points are switched. 8, 2. Oh. 8, 3. Sorry. Log base 2, 8 is 3. And this one has a vertical asymptote. So down the middle there, this is the log graph. Log base 2x. Okay, so now when we're thinking about what's happening with these graphs, with these transformations, right? It's going to take this whole graph, every point, it's going to pick it up, and the points are going to go to the left 3 and then down 1. So the points, I'll do the transformed function, I guess, in purple. Each point will go to the left 3 and down 1. Left 3, down 1. Left 3, down 1. Left 3, down 1. And in the same way that I moved every point to the left 3 and down 1, I can also move the asymptote to the left 3. Now moving it down 1 is kind of irrelevant, but I'm moving my asymptote to the left 3. So the graph, the transformed graph looks like that. The new asymptote is now at x equals -3. And I can do the domain and the range of this graph. So the domain sort of, when you think about where the graph starts at -3 and it goes on till infinity. But the range goes all the way from the very bottom, from -infinity up to infinity. So the domain goes from -3 to infinity. Don't include the -3 because that's an asymptote. It can't be -3. And from -infinity to infinity. As x gets closer to -3, what happens to the graph? It goes down towards -infinity. As x approaches infinity, the graph goes up towards infinity. Okay. Now we can take this graph and transform it. Similarly, we're going to transform this graph by going right 1. That's going to cause a right movement, and up 4. So I'll take every point and move it right 1, up 4. Right 1, up 4. Right 1, up 4. Yeah. So this one's going to run off right 1, up 4. It goes up here somewhere. So in addition to each point going up, I'm also going to move the asymptote up 4 units. So now the asymptote is here. It's 4 units above where it used to be. So when I think about, I didn't do a very good job in the last one labeling these arrows. This would be infinity, infinity. Over here would be -infinity, 4, right? It's close to 4. It's not on 4, but it's very close to 4. Would be how I would label the end of this arrow. It's just getting closer and closer to that asymptote. So the asymptote is horizontal. It's y equals 4. The domain from -infinity to infinity. And the range from 4 to infinity. Don't include the 4 because there's an asymptote there. As x goes towards -infinity, y gets closer to 4. as x goes towards infinity, y gets closer to infinity. Number 50. Where's the next page? Here it is. 51. Okay. Convert between exponential and log form. My favorite one is 2 cubed equals 8. And then I write down log base 2, 8 equals 3. And that just helps keep me grounded. And then I can switch anything. So 3 to the p equals 70. That's exponential form. So if I want to write it in log form, it's log base 3, 70 equals p. Log base nq equals 15. There's my base. I just set it. N to the 15th equals q. Okay. When we condensed log expressions, we had 3 rules. We had the power rule, the product and quotient rule. So the product and quotient rules kind of gotta go together, and then there's the power rule. So if I'm condensing, I'm going to do my power rule first, and then my product and quotient rules. So I'm going to bring up this power. It'll go here, log base 5, 16 to the 1/2 power, minus log base 5 x cubed, plus log base 5 y to the 4th power. Now, since these are all log base 5, I can condense using the product and quotient rule. Before I do that, though, 16 to the 1/2 power, that's just 4. That's the square root of 16. So I'm going to just make that one change really quick. Okay. So now when I condense, first I can use the quotient rule here. Use the quotient rule, that's subtraction, so it condenses down to this 4 over x cubed. Because this is being added, when I condense that in, that ends up in the numerator also. So log base 5, 4x to the 4th over x cubed. Okay, solving exponential and log equations involves the old switcheroo. And so we're going to start by isolating the exponential part here. For the next one, we'll be isolating the log portion. So I will do plus 45 to both sides, plus 45. This becomes 125 equals 5 to the x minus 5. If it helps you to switch the sides so you have base exponent equals answer, you can do that. Because the way that I'm going to solve an exponential is by switching it. Log base 5, 125 equals x minus 5. Log base 5, 125. Hey, 5 to what power is 125? It's the 3rd power. So x is 8. And of course I can check that by plugging it back in here. So 8 minus 5 is 3. 5 cubed is 125 minus 45 is 80. Next one, I'm showing that I'm going to isolate the log portion, so I'll do that by adding 4 to both sides. And I'll get 3 equals log base 2, 3x minus 2. And again, I'm doing the old switcheroo to solve, so that's 2 cubed equals 3x minus 2. Oh. Well, this was not very good. This is why I look over my work a little bit before moving on. Why would I add 4 to both sides? That's not really going to get the job done. Let's add 5, you know? Let's go all out and add 5. Okay. Add 5 to both sides, why don't you? And then this side becomes 4. That's a little bit better. Now we'll do the switcheroo. 2 to the 4th power equals 3x minus 2. 2 to the 4th power is 16 equals 3x minus 2. Add 2 to both sides. That I have correct. 18 equals 3x, and divide by 3. X equals 6. And again, you can check this really quick by plugging it in. So 6 times 3 is 18 minus 2. That's 16. Log base 2, 16 is 4. 4 minus 5 is negative 1. Okay, solve a log equation where you have to condense first. So for this one, this is very similar to the condensing that we did on number 53. We're going to first do the power rule, right? So that becomes an exponent, and 3 squared is 9, so let's go ahead and do that as well. Log base 5 x plus 6 minus log base 5 9. So that's log base 5 x plus 6 over 9 equals 1. And now it's time for the old switcheroo. Base exponent equals answer. 5 to the first power equals x plus 6 over 9. Well, if you put that over 1, you could solve by cross multiplying. So I got 45 equals x plus 6. Subtract 6 from both sides, and I got 39. And of course, you can check it by plugging it in to see what happens. I guess you'd have to kind of use a calculator there, because I don't know log base 5 45, but you can do it on a calculator. Okay, let's move on to number 60. I must have just one page left. Oh, it's on the back. Yeah, sorry, 61. It's hard to go from 59 to 60, but that's what we're doing. Now, you are going to have your formulas provided, so I'm just going to grab my formula sheets here. This says an arithmetic sequence, so I'm looking for the number that I am adding each time. So that's D. That looks like it's -7 is the number that's being added each time. So I'm going to write my explicit rule again, formula sheets right here. I need this explicit rule. So I'm just going to plug in the pieces that I know, A sub 1 and D. So A sub n is 4, the first term, plus n minus 1 times -7. So if I want to find the 50th term, that's called A sub 50, I do 4 plus 49 times -7. And I'll grab a calculator. Of course, I don't have one. We'll get one. 44 plus 49 times -7. -339 is what I got. That's A sub 50. That's the 50th term. Determine the sum of the first 30 terms. Well, to do the sum, right, we're going to do the sum formula. This one here. That's my sum formula. I'm going to plug in 30 for n. Sum of 30 terms is 30 over 2. 2 times A sub 1, so 2 times 4 plus 29, because that's n minus 1, 30 minus 1 times D. And I'm going to depend on my calculator a little bit here. 29 times -7 plus 8. That's 15 times -195. -2925. Okay. Next, we've got a geometric sequence. First, we've got to figure out what R is. And so the shortcut is to just divide the second term by the first term. So R is 3/2. You would get the same thing if you divided 9/2 divided by 3. You get 3/2. Write the explicit rule. So A sub n equals A sub 1 times R to the n minus 1 power. And then I'm going to plug in 8 to find the 8th term. A sub 8 is 2 3/2 to the 7th power. Okay. So in my numerator, I'm going to have, I'll put this over 1, 3 to the 7th power, which is 3 to the 7th, 2187. So my numerator is 2 times 2187, right? 2 times 3 to the 7th, and then 2 to the 7th power is 128. And I'm writing it like that to make it a little easier for me to simplify without a calculator, because 2 over 128 is 64. So this becomes 2187 over 64. Find the sum of the first 10 terms as a fraction. So I need to go and grab the sum formula. So again, this is geometric, so I'm going to this sum formula right here. A sub 1 minus r to the n power, to the 10th power, over 1 minus r. And for me, I could work this out a different way, but you know, here we go. We've got a nice calculator right here. And as long as I'm faithful in putting it in correctly, that's raised to the 10th power. And in the denominator here, you can do 1 minus 3.5, or you can just go right ahead and put negative 0.5 if you want. That's what 1 minus 1.5 is. And then I think everything looks pretty good. Oh, it's not giving me in fraction form. So what can I do now? Some of the first 10 terms as a fraction. Okay, I can do this. Might be harder than I want. But I can do this. Okay, so let's do it as a fraction. N minus 3 halves to the 10th power. So I need more paper, that's for sure. I was hoping to be almost done with this thing. Let's get a little bit of paper. Okay, let's do 2 times 1 minus 3 halves to the 10th. So I'm going to do 3 to the 10th. That's 5904549 over 2 to the 10th. 1024. 1 minus 1.5 is negative 0.5. Right? Let me move this up a little bit so we have some more space. Okay, I can go ahead right now and I can divide 2 divided by negative 0.5 is negative 4. How many times is negative 1/2 going to 2? Negative 4. So this I can change to negative 4, 1 minus 59049 over 1024. And I think I'll just get a common denominator here and subtract these next. That seems reasonable. My common denominator, of course, is 1024. No fear. 1024 minus 59049. I need a calculator for that. Is negative 58025 over 1024 times negative 4 over 1. And now I can simplify this. Well, first of all, it's going to become positive because it's negative times negative, right? So it'll be a positive answer. And I can simplify this by canceling out the 4 and the 1024. So that's definitely divisible by 4. It's 256. And of course these also cancel, right? Like it's going to turn out to be positive. So 58025 over 256. Now, was that a little bit crazy to go fraction on that? Yeah, it was a little bit crazy. I'll admit it. Not my best question. Okay. Could you do it? Yeah, you could. Just common denominators, not a big deal, but you know, it was a little crazy. Okay, sum of an infinite series. I think this one's going to be easier. I feel better about this one. So let's see. I have to figure out what R is here, right? What am I multiplying by? It's an infinite geometric series. And of course, the shortcut to find R is just to take the second term divided by the first term. And 16 over 20 becomes, that's divisible by 4. That's also divisible by 4/5. There's R. My formula is, grab right from the formula sheet, a sub 1 over 1 minus R. So that's 20 over 1/5. So that's 20 over 1. So keep, change to multiplication, and flip over. So that's 100. Done. Permutation and combination. On a team of 15 players, in how many ways can 2 co-captains be selected? Well, if they're co-captains, it doesn't matter who's picked first. So that's a combination question. You've got 15 people to choose from, and you're going to pick 2 co-captains. So what we discovered, of course, after the fact is that you have a probability button on this calculator. And you have 2 choices, probability, well, you also have a factorial button, but probability or permutation or combination. Now, the way that this works to enter it on the calculator, and I'll show everyone in class too, is to go 15 and then go to this button and then put the 2. So you put the 15 combination 2 and poop, it'll spit it out for you. 105 is the number of ways that you could select 2 co-captains. 250 teachers entered a raffle for 3 cash prizes, $10, $100, and $1,000. In how many ways can the winners be selected? Now for this one, the order does matter, because if I'm one of these 3 teachers, I definitely want to get the 3rd prize. I don't particularly want the $10, I want the $1,000. So this is a permutation. We've got 250 teachers vying for 3 prizes. Sounds about right. So we'll do 250 and probability. Oh, pick permutation. Put 3. It's going to be a big number. Yeah. 15,438,000 ways. 15,438,000 ways. Wow. Okay. Normal distribution. Final exam grades are normally distributed with a mean of 80 and standard deviation. What % of students would be expected to score above 94? Well, you know, I love to draw a picture. Here's 80. 1 standard deviation above would be an 87, and then 94 would be here. We'll go down to, 73. Go down 7 more, that's a 66. Okay, we want to know what's over here. Well, since this is sort of one of those nice numbers, right, I know that this space right here, within 2 standard deviations of the mean, I know that that's 95% of people. So these 2 little tails out here, this one and this one, are 5% altogether. The highlighted area is 95%. So these together are 5%. So if I want to know who's going to score above 94, that's going to be 2.5%. What % of students would be expected to score less than 70? So 70 is not one of the pretty numbers, right? So that's when I'm going to need my z-score. So I'll do a z-score, 70 minus the mean over 7. So that's negative 10 over 7. And I'll go 10 over 7. That's negative 1.43. I go to my z table. Find one. Oh no. I need a z table. There's one. Okay. On the z table, I'm going to go to negative 1.43. That's right here. 0.0764. I'm going to just write that down and then figure out what to do with it. 0.0764. Okay. So what that means is, if I'm thinking about my thing, here's 70, right? We always find what's to the left here. So 7.64% of people are going to score less than 70%. Okay, that was it. All right.